Okay, so the problem that I'm going to be doing today is a motion problem. So, a man wakes up from rest and runs down the stairs. With a constant acceleration of 3 meters per second squared. If he ran for 8 meters, how long did this take? And what was the man's final velocity? So what is this problem asking? It's asking for you to find how long it took for the man to run 8 meters, and what was the man's final velocity. So first we have to see what the problem already gave us to help find our answers. So the problem already gave us the acceleration, which is 3 meters per second squared, and the displacement, which was 8 meters. We can also infer that since the man wakes up from rest in this problem, his initial velocity is actually 0 meters per second. Okay, so now that we figured out the stuff that we already had in the problem given to us, we can figure out the time by putting the stuff we already have into the displacement formula. Now, the displacement formula is x equals initial velocity times time plus 1/2 times acceleration times time squared. So, what would we do with this? Now, we would plug in with what we already have. So, for x, we would plug in 8 meters equals, and then for initial velocity, we would put 0 times time, since we don't have time yet, plus 1/2 times 3 times time squared. So we can already get rid of this since it's times a 0, so it crosses out. So then we have 8 meters equals 1/2 times 3 times time squared. So after that, we can figure out this by timesing 1/2 with 3. Then we would have 8 meters equals 1.5 times time squared, which would allow us to divide 1/5 against 8, which would allow us to have a 5.3 equals times square. And to get rid of the square, you can square it. Square the other side too, which would give us 2.3 equals time. So then we already figured out the time, which is 2.3 seconds. So that already answers one of our questions. How long did it take? It took 2.3 seconds. Now we can also use dimensional analysis to figure this out too. So we put 2 times the displacement, which is 8 meters, divided by the acceleration, which is 3 meters per second square. So the meters would cross out eventually. You would times 2 times 8, and then divide that by 3, and you would get 5.3 seconds squared. Now we don't want the seconds squared because we need the times. So we would square that to get rid of the square, and we would get 2.3 seconds. So that would be our time in a way to figure it out through dimensional analysis. So, since we were able to figure out the time, now we are able to figure out the second part of what the problem is asking. That is, what was the man's final velocity? So, we can figure out the final velocity by using the acceleration formula. Now, the acceleration formula is acceleration equals final velocity minus initial velocity over time. So we would plug in what we already know into here. So we know the acceleration, which is 3 meters per second squared, equals, now we don't know the final velocity, so we leave that by itself, minus the initial velocity, which is 0, since he starts at rest, over time, which we just figured out was 2.3 seconds. So, now that we plugged everything in, we can solve it. So, first you would times by itself, which would cross that out. You would times acceleration by your time. So, by timesing these, you would get 6.9 meters per second, which would equal to the final velocity. We can also take this and do the same thing that we did for the displacement formula and put it in dimensional analysis, which would look like this. And we get the exact same answer. So now we have the answer to the first question, which was how long did this take? And it took 2.3 seconds. And what was the man's final velocity? So the man's final velocity was 6.9 meters per second. This was Michael Dichele, and this was my motion problem. Thank you.